Today, we're going to unpack a mind-bending new discovery that is literally tearing up physics textbooks as we speak. We're looking at some fresh, completely groundbreaking findings published in the journal Science by researchers at the Brookhaven National Laboratory. And what they've found fundamentally changes how we understand the very center of atoms. So let's just dive right into this mystery. If you took high school physics or chemistry, you probably remember learning about protons. You were taught a very neat, very clean model of what sits inside them. But what if I told you that simple picture is missing a hidden, invisible structure that is the literal reason you and I currently exist? Section 1, the textbook Proton Myth. Let's look at what we used to believe. The crucial point here is that textbooks usually show this super simple 3-quark model. But the reality? Oh, it's way more chaotic. Researcher Tommy Tong points out that the naive quark model just pictures 3 main valence quarks sitting nicely inside a proton. But look at the actual details inside, and it's basically a bustling, chaotic quantum soup. You've got a sea of interacting gluons, literally the glue holding quarks together, and quarks and antiquarks just constantly popping in and out of a vacuum. Section 2, why matter actually survives. Because why don't protons just decay? All right, before we get to our particle collider crime scene, we've got to understand the stakes. This brings us to a concept called the baryon number. Think of this as a strict universal accounting rule. In physics, conservation of baryon number means the total number of baryons, which are those 3-quark particles like protons and neutrons, absolutely must remain exactly the same before and after any collision. This rule has been a constant since the Big Bang. Traditionally, scientists just assumed this baryon number was neatly divided up, with each of the 3 valence quarks carrying exactly 1/3 of the load. And this invisible, perfectly conserved number is absolutely vital. As star physicist Nicole Lewis explains, the lifetime of a proton is believed to be longer than the lifespan of the universe itself. The baryon number is literally the reason protons don't decay. It's what allows atomic nuclei to form and be stable. It's the reason matter exists at all, keeping you, me, and the entire universe from vanishing into thin air. Section 3, the particle collider anomaly, a mystery at Reich. With those massive stakes in mind, let's head to our crime scene, the star detector at the Relativistic Heavy Ion Collider, or RHIC. This is where scientists smash atoms together at near light speed to see what spills out, and during these highly energetic collisions, they noticed a really bizarre anomaly. The detector was consistently recording an unexpected excess of baryons, matter particles basically, shooting out perfectly perpendicular, or sideways, to the incoming colliding beams. To understand why this sideways explosion of matter was so puzzling, you have to look at the math. If quarks alone carried the baryon number, like the textbooks claim, explaining this sideways excess would require a totally improbable sequence of events. All 3 valence quarks from a colliding proton would have to slam on the brakes and stop perfectly near the center. Then, they'd have to undergo an extreme conversion from matter into energy and then back into matter, producing new baryons that just so happen to move perpendicularly outward. The mathematical improbability of all 3 quarks flawlessly coordinating this routine was a huge red flag. Section 4, tracking the electric clue. It's time to track some quarks. Realizing the old textbook theory just wasn't cutting it, the STAR team turned into full-on quantum detectives. Led by Zibo Tang at the University of Science and Technology of China, they found a brilliant workaround. They decided to use the quark's electric charge as a sort of tracking device. By measuring the electric charge coming out perpendicular to the collision, they had a definitive way of counting exactly how many quarks were stopped in their tracks. And the mismatch they uncovered was just undeniable. When they compared the net baryon number with the redistributed electric charge, the numbers totally didn't add up. Just look at the massive discrepancy here. They observed roughly twice as many baryons as should have been produced based on the stopped quarks. Twice as many. According to the data, far too few quarks were actually stopping to create this much sideways matter. So, if the quarks weren't carrying the baryon number into the center of the collision, what on earth was? Talk about a cliffhanger. What exactly was carrying this fundamental property of matter? Section 5, the Y-shaped gluon magnet, looking past the quarks. To answer that cliffhanger, we have to look past the quarks themselves and look at the glue holding them together. We have to look at the gluons. And what's wild is that this theory has been hiding in plain sight for decades. Physicists first proposed a baryon-gluon junction back in the 1970s. But in 1996, theoretical physicist Dmitry Karziev proposed something radical, that this junction, not the quarks, carries the baryon number. It literally took 50 years of theory, the opening of RHIC in 2000, and massive technological leaps for the STAR collaboration to finally publish hard evidence for this in 2026. So how does this hidden mechanism actually work in practice? Well, as protons are accelerated to enormous energies, their momentum spreads out among a multiplying number of gluons. Because the rapid valence quarks carry most of the forward motion, they're incredibly hard to stop, so they just zip right straight down the beam pipe during a crash. But the slower, central Y-shaped junction of gluons, that gets left behind. As STAR physicist Predwish Tribady notes, it's just a lot easier to stop one connected gluon structure than it is to stop 3 separate, fast-moving quarks. Once that junction is violently stopped in the center of the collision, its energy has to go somewhere, right? So this stopped 3-pronged gluon junction begins to act exactly like a Y-shaped magnet. It literally draws in 3 brand new quarks straight out of the vacuum to build a completely new baryon that shoots out sideways. Mystery solved. The quarks didn't stop to make the matter. The hidden gluon junction did. Section 6, Rewriting the Universe. Why this fundamental shift matters. Let's zoom back out from the quantum level for a second and look at why this matters to you and me. Remember, these collisions are incredibly violent. You start with nuclei containing roughly 100 protons and neutrons. When they crash, 99% of the energy is transformed into thousands of brand new particles. Absolute chaos. But even with 99% of the energy transforming, the baryon number, that strict universal rule we talked about, is perfectly conserved and safely transported by these hidden Y-shaped gluon junctions. And this leads to a profound realization from Brookhaven Lab physicist Rong Ma. By proving that gluons, the glue itself, transport this vital property, we've completely upended a defining quantum feature of the proton. We always thought the quarks did the heavy lifting for the stability of matter, but no, it's actually the structural glue connecting them. We literally have to rethink the structure of the most fundamental element responsible for the universe. Which leaves us with a fascinating, almost unsettling question. If the classic textbook building blocks of matter were hiding such a complex, vital secret for this long, what other invisible structures are waiting to be discovered right inside our own bodies? It really makes you wonder exactly how much of our fundamental reality is still waiting to be uncovered in the quantum shadows.